This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video, we will be looking at how to use the trapezoidal rule. So the trapezoidal rule is a way to estimate the area of an irregular shape such as a curve where we have no formula to find the exact area. So the idea is to try and estimate it by splitting it into smaller shapes that we know how to deal with, accepting the fact that we won't get the exact area. So the above here is taken from the Leaving Cert Tables book and shows that we can find the area of this shape given by A is approximately equal to, so these little wavy equal signs, h over 2 all multiplied by y1 plus yn plus 2 times y2 plus y3 plus y4 plus and so on, all the way up to y plus n minus 1, so the second last height that we take. So the trapezoidal rule is best seen when we look at an example. So let's say we're given the function f of x is equal to minus x squared plus 4. And we're asked to, using the trapezoidal rule with h equal to 1, find the area between the curve f of x is equal to minus x squared plus 4 and the x-axis from minus 2 to 2. So first of all, we'll see what this looks like. So on the left hand side here, we see this is a plot of the function, the blue line, minus x squared plus 4. And we can see on the right hand side, these red shaded regions are going to be what we will use to estimate our area using the trapezoidal rule, where h, which was 1, is the distance between each of these shapes. So h can easily be a half, h could easily be 2. In this case, h is 1. So essentially it comes down to finding the area of these 4 shaded regions. So using the formula, we obtain the following. h over 2 becomes for us 1 over 2 as h is equal to 1. y1 is now f of minus 2. The reason being is that is the height when x is equal to minus 2. y5 is equal to f of 2. Again, the far right point in this diagram, the height when x is equal to 2. We then have plus 2 times f of minus 1 plus f of 0 plus f of 1. And again, this is y2, y3, and y4. We see that f of minus 1, f of 0, and f of 1 correspond to, when the x value is minus 1, 0, and 1, it corresponds to the height of these black circles. So f of minus 1 corresponds to the height of this black circle, f of 0, the height of the middle black circle, and f of 1, the height of the black circle here. So, subbing minus 2, 2, minus 1, 0, and 1 into our formula, f of x is equal to minus x squared plus 4, we end up with that the area is approximately equal to half times 0 plus 0 plus 2 times 3 plus 4 plus 3. Now the first two numbers in our case were 0, because as we saw in the diagram, the heights at that point were 0. The black dots sat on the x-axis. They had no y value. This won't always be the case. These values may not always be 0. It just so happens in our example that they are. We see then that the area is approximately equal to half times 20, giving us that the area is approximately equal to 10 square units. And using calculus, we can actually find that the actual area is equal to 10.667 square units. So we can see that without a lot of work, we came up with quite a good approximation.